All right, gentlemen. Let's see. Testing, testing. Yep. Looks good. All right. So, welcome. Let me see. As far as announcements go, so hopefully everyone enjoyed their fall break, right? On Monday morning, I logged in at 9 o'clock, and I was like, "Yo, where is everybody?" And then in an instant, I was like, "Oh, that's right. We have fall break." I went and checked the syllabus, and sure enough, it was fall break. So I was like, "Oh yeah, doing the Carlton. Oh yeah. Oh yes." I had Monday and yesterday off essentially, but you know how things go. People in your circle find that you got the day off. Oh, great, you can come help me with this. It's like, no, I can like take a nap and play some video games and eat some snacks and things. All right. But no, I want to help the people. I mean, obviously I'm not gonna ignore people, but yeah, so we're back today. So normally today we will be going through the homework. We're going to take today to do the lecture that we would have done on Monday. So after today, we're going to be working on section 1.6, combining functions and composite functions. And then I want to say that exam 2 should become available this Sunday morning at 11 a.m. It'll be available. You can earn up to 100% for the first 7 days. So after the first 7 days, it'll be due. If any question that you submit past the due date, there's a 5%, 5 to 10% late penalty, right? As always, if you have questions, feel free to unmute yourself or type in the chat. I don't think I'm gonna use my microphone today. You're good. All right. So yeah, let's hop on into it and get the party started. Anybody that got an interesting experiencing anything interesting over the break, feel free to either unmute it or put it in the chat. I was riding around town. It's not really that interesting, but was riding around town and I saw literally like a car-sized spider on the side of a building. I was like, why is that spider like ginormous, right? Come to find out, that ended up being like the entrance to Netherworld. I was like, oh, the haunted house place. I was like, oh yeah, I think I'm gonna go this year. Um, so I kind of do want to check that out. Yeah, so that was my little interesting story for the weekend. So I'll in the next couple of weeks I'll try to make my way over there at some point. Okay. So section 1.6, combining function and composite functions. Let's do a quick recap. So 2 weeks ago, we started section 1.4, a library of functions. And so that's where we were laying the foundation for graphing. And so we went through like several base functions, like a constant function, linear identity function, linear function, or I guess you could say identity function, and then a squaring function, cubing function, absolute value, square root functions, greatest integer function, which is a step function, stuff like that, right? So that was 2 weeks ago. Last week, we explored manipulations on those base functions. So we explored transformations of functions. So I think we reviewed a total of 10 transformations altogether. We had I think 6 rigid transformations and then 4 non-rigid transformations that would distort our graphs or whatever. So between plotting points, using a library of functions with transformations, those are some of the main techniques that we have so far for graphing functions, right? So we have the list or plotting points. Okay. So then we're going to take it a little bit further and we're going to explore combining functions. What do we mean by combining functions and composite functions? The simplest way I can summarize combining functions, essentially what it is just doing arithmetic with multiple functions. Adding functions, subtracting functions, multiplying and dividing, things of that nature. We'll see in just a moment. We'll see momentarily what do we mean by composite functions. So a few objectives here. One, we'd like to define basic operations of functions. 2, form composite functions. 3, find the domain of a composite function. 4, decompose a function. And 5, apply composition to practical problems. Ooh, oh yeah, I can just grab this. Oh yeah, let's go. I'm getting a little giddy because I got my setup where I'm standing up today. So I'm using my iPad kind of like a mic and like a teleprompter. And I got my keypad as like a clicker. So but I had this urge to walk around like I'm in front of an actual audience. But I know if I get too far away, you won't be able to hear me. Anywho, so what do we mean by sum, difference, product, and quotient of functions? Let f and g be 2 functions, the sum f plus g, the difference f minus g, the product f times g, and the quotient f divided by g are functions whose domain consists of those values of x that are common to the domains of f and g, except for f divided by g, where all values of x where g equal to 0 must be excluded. These functions are defined as follows. Okay, let me say something here. So again, all we're really doing is, doing arithmetic with multiple functions. When it comes to the domain of our final result, for right now, we're going to take, if we take the domain of f, find the domain of g, and take their intersection. For right now, that's going to be the domain of the final. And then whenever we're doing f divided by g, there's an added stipulation that we have to remove any x that makes the denominator 0, because we cannot divide by 0. So if we have an x value that generates a 0 denominator, we have to remove that from our domain. All right, and so here, all right, so this is, sum of two functions, right? This just means f of x plus g of x. This is difference of two functions, f minus g, so on and so on and so on. A common error when students see this, I always alert the students, and inevitably somebody forgets, it doesn't register. This is not multiplication. The common error is that students try to distribute that, and that's not what's going on here. All right. So just be sure, we're not distributing there. That's not what's going on. So what this just means the function f plus the function g. This just means the function f minus the function g. And here we do need to distribute a negative, right? We got to watch out for that too. This just means the function f times the function g. We might have to do some foiling there. This just means the function f divided by the function g. And again, we have to remove any x that makes the denominator 0. Okay. So, if you fall into the habit of trying to distribute an x, you might get one or two correct, but in the long run, you're going to get more wrong than right, because that's not what's going on here. Okay. So given this f and this g, we're asked to find each of the following. Okay. So, okay, let me get a copy. I want to do that. We'll just do it manually for now. That's fine. So let me get a copy of this and generate some space. All right, that's decent. All right, and I will just use it as a reference. Okay. Let me go like this. Down just a bit. All right. So for part A, right? So we have f minus g of 4, right? So I'll do f in this burgundy color right there. I'll do g in green just to make it pop a little bit. Okay. Let me divide up my page. So what does this mean? This just means what? F of 4 minus g of 4. Okay. So what we could do here is find f of 4, we get an answer. Find g of 4, we get an answer. And then say the first answer minus the second answer, right? Okay. So then f of 4. So first I'm going to start by replacing each x with a blank set of parentheses. Okay. And then I think 4 goes into each parenthesis, each blank parenthesis. Okay. So then if we keep going, that's going to be what? 16 minus 24 plus 8, I think is 0. That's a 4, 24. Yeah, 0. Okay. So the first result we got was 0. Let's go ahead and find g of 4. So we're going to place each x with a blank parentheses, and 4 is going to go into the blank parentheses. 4 minus 2 is 2. Okay. So then if we say f of 4 minus g of 4, that's going to be equal to 0 minus 2, which is ultimately negative 2. Okay. Oh, undo. Okay. All right, so then let's work on B. So we're going to say F divided by G of 3. Okay. What does this mean? All this means is F of 3 divided by G of 3. Okay. So we're pretty much going to do something similar. Find F of 3, we get an answer. Calculate G of 3, get an answer. First answer divided by the second answer. Okay, so F of 3, let me see, x squared minus 6x plus 8, or x is 3 in this case. That's a 9 minus 18 plus 8. Ultimately is -1. Okay. And then G of 3 is 3 minus 2, which is a 1. So then duplicate. When we do F of 3 divided by G of 3, it's going to be -1 divided by 1, which is ultimately -1. That duplicate feature that they added just made it so much more seamless. I used to have to like copy and paste, and this is way faster if I could just duplicate stuff. Okay. So we did A and B. Let's go ahead and do C and D. So let me see. I guess I could just, let me just copy, paste. Okay. And I'm going to go ahead and divide up my slide. Oof. Okay. So then for C, we're doing what? F plus G of X. So F plus G of X. Okay. What does this mean? All this means is F of X plus G of X. Okay. I'll start off with the colors and then I'm going to stop using the colors. So this is just going to be F of X is what? X squared minus 6x plus 8 plus G of X, which is X minus 2. Okay. Notice that we don't have any, like, we don't have to distribute anything here. Like, we're not doing multiplication over addition, or we don't have any negative we need to distribute. So we could actually just lose the parentheses and combine like terms. Okay. So I'm just going to go ahead and combine like terms. We're going to have x squared. Let me see, -6 plus 1 is going to give us a -5x. 8 plus a -2 is going to give us a 6. So then this should be our final result. Again, all I did, you can just lose the parentheses because there's nothing to distribute, and then we combine like terms. Okay. Maybe I might be able to fit D here. I think I got that one already. Okay. So then with D, F minus G of X, okay? So then F minus G of X. And what does this mean? This just means F of X minus G of X. Okay, what do you think is going to be the little trick here? What do you think we have to watch out for? All right, I kind of want to give you, take about 30 seconds. Just take 30 seconds and try to work through this one a little bit. I'm watching the clock. We still got like a good 25 seconds. I'm just curious if you can see the little trick here. Let's see what she means. Okay. All right. Okay. So with this one, like with the first one, we really didn't need the parentheses. This one, you definitely want to use the parentheses. Okay. So our f of x, let me see, this is going to be equal to our f of x parentheses x squared minus 6x plus 8 minus g of x, which is x minus 2, right? So without these parentheses here, it's easy to miss that we need to distribute this negative, right? So this is one of those cases where that's why I wanted you to kind of try it yourself for a moment and see, did you catch that you needed to distribute a negative? Because if you don't distribute a negative, it's going to be wrong, right? In this case. Okay, so if we distribute the negative and combine like terms, we'll finish with x squared minus 7x. 8 plus 2 is 10. That's right. X squared minus 6x. Okay, we said f minus g plus 2. Yeah, this looks okay. Duplicate. And like the weather is wild. Like, you know, I know there's people in Florida trying to escape. They're running out of gas, getting stuck on bridges. Here it's like beautiful. It's like, am I thinking of this right? And then, you know, North Carolina just got flooded where they don't usually have floods. I'm like, here we go. They on the ish, you know. Okay, anyway. So then part E. Okay. So then E, f times g of x. So then f times g of x. Oops. Again, what does this mean? This just means f of x times g of x. Another, just a random thing, a tangent. This Sunday is the second Sunday of the month. So I want to say it's free admission at the High Museum. So like if you just want something to do that's free, the High Museum, free admission. You can go online now and get tickets. It's high.org. It's just free marketing for them. It's just something free to do that's fun. I think they're going to have an exhibit with Alicia Keys and Swiss Beats. I think they made some artwork. So a friend of mine was like, yeah, you want to go to this? I was like, yeah, let's go. So you might catch me up there. Okay, guys. I think it's open from like noon to 4. So, okay. So if we keep going. So our F, okay, I'm going to just, you know what? I'm going to just duplicate this. Duplicate. And instead of it being plus, that needs to be times. So I'm just going to move these guys together, right? So we just said F times G, okay? So then here we have a trinomial times a binomial, so we need to FOIL, right? Or distribute properly, okay? So let me see. The first term is going to be x cubed minus 2x squared minus 6x squared plus 12x. And then plus 8x minus 16, okay? I just said the first term times the green plus the second term times the green plus that third term times the green. I got this result. So then we combine like terms. It's like minus 8x squared plus 20x minus 16. Okay. Hopefully we're all aboard and we're not all bored. I know this can be kind of tedious. And again, as usual, if you have questions, let me check the chat real quick. Either feel free to type your questions in the chat or the Q&A, or feel free to unmute yourself. Let me just check on you guys real quick. Uh-oh, did I get booted? Let me join. Don't connect the audio, join. Yeah, I think we look okay. Q&A looks good. Let me just check over here just to make sure, since that got booted. Close. Okay, you guys look okay. Okay. All right, let's go ahead and do F. So then we have F divided by G of X. So we're going to say F divided by G of X. Okay. Hopefully you're catching on by now. This just means F of X divided by G of X. I'm just going to duplicate this instead of writing this over and over. I'm going to duplicate and position it properly. All right. So this guy can be simplified, right? Can anybody tell me, with the bottom is going to stay as x minus 2. We want to see, can we factor the top into some form like this, right? How do we fill this in? Can anybody factor this? Like either put it in a chat or, the audio. I just want to give you like a few seconds, 30 seconds max. Just see, can you factor this, right? Just give it a go. Let's take about 10 more seconds. Okay, so I saw a guy over the weekend that he said that he showed where he can like make 3 voices come out of his mouth, and it was kind of like beatboxing, but he did it. He was like he's like, I can't do it though, because it's like, well, like when I beatbox, I at least have 2 different sounds. It's like you're humming with the beatbox, so it's like so you can get 2, but somehow he got a third one in there. And I sat there and watched him do it. I was like, man, that's weird, but I got the concept. Okay, so here, right here, what we're trying to do. Okay, so 2 numbers that multiply. Look, so I usually like to start with the second sign. Because the second sign is positive, I know my 2 signs need to be the same. They're either both positive or they're both negative, right? And then the first sign tells me the sign of the larger number. So because my first sign is negative, that tells me the larger number is negative, right? Anybody get it? Let me just check real quick. It looks, oh, you guys are making me nervous. Nobody's there. All right. So the plus tells me the 2 signs are the same. The minus says the larger is negative. So that means they should both be negative. Right. So I'll do this color. So they should both be negative. 2 numbers that multiply to give us 8, add to give us 6 are 4 and 2. Okay. And then now you can see that this is going to cancel. So now we're going to finish with x minus 4. We need to add the stipulation that x cannot be 2 because 2 is going to generate a 0 in the original problem, right? So when we did f divided by g, we still have to remove x equals 2 from our result, all right? So if we were to look at this graph, it would just be a diagonal line with a y. It would be a diagonal line with a slope of 1 and a y-intercept of -4. But then there would be a hole or a gap when x is equal to 2. All right, so there's going to be a hole or a gap when x is 2. You find the corresponding y, and there's going to be a hole or a gap at that point. Okay. All right. Let's duplicate this. Okay. So I was able to save on the page. So yeah, with this course, we do expect you to have some level of familiarity. I can barely get that word out when it comes to factoring, right? I think this section there's no lab component, so but for anybody that wants additional support on factoring, just like a refresher or some practice on factoring, if you log into Blackboard, you're going to see and open up our main folder. You're going to see the Zoom link. I think that second link says, daily lecture notes box link. You open that up, and then you're going to see like about 4 or 5 folders. I think it's about the 4th or the 5th folder is going to say handouts. In that folder that says handouts, you're going to find 2 documents. The first document is actually this one here. I decided to go ahead and include it in today's lecture. And so what this document is saying is it's an overview or a summary of how to approach a factoring problem. So whenever you have a problem that needs to be factored, this is a procedure, a set of questions you can ask yourself to follow in order to factor it. All right, we're going to go through this in just a moment. The other document that you're going to find is a copy, a digital copy of a chapter, an entire chapter devoted to factoring. I pulled it from like an intermediate algebra text when I was in grad school. I've been using it for over a decade, and it pretty much will touch on like at least 90% or higher of the factoring scenarios we'll come across in this course, right? It's just added practice. If you need a refresher or a review on factoring, it's like a few sections. Each section has problem sets in the back, and they kind of walk you through the different scenarios, right? So let's recap this summary. So when we go to approach a factoring problem, the first question we might ask ourselves: Does the expression have a greatest common factor, a GCF? So if you see a factor that's common to all the terms, then we factor out the greatest common factor. So then from there, then we identify, okay, how many terms are left? Do we have 2 terms, 3 terms, or 4 or more terms, right? If we have 2 terms, then it's going to be it typically is one of these special cases. It might be difference of squares, difference of cubes, or sum of cubes. Notice there's no sum of squares, all right? There's no sum of squares, right? So if we have 2 terms, typically it's one of these guys, okay? If we have 3 terms, now they have different techniques here, perfect square trinomial or some of these others. I typically like to do like kind of similar to what you saw me do just a moment ago, where it's basically called the AC method, where I'm going to say my leading coefficient times my constant. I'm going to get a number, then I'm going to look for 2 numbers that multiply to give me that number and add to give me B. And then from there, I typically like to do the box method. So I know the previous one, the leading coefficient was a 1, so it was much easier. But I kind of use that same technique for all of this whenever I'm doing factoring 3 terms or a trinomial. So you'll see, if you haven't seen me do it already, hopefully we'll get some chances to kind of demonstrate that. And then if it's 4 more terms, the technique that we want to use is factor by grouping, right? So we might try grouping them in different ways and seeing, can we get a common binomial factor, yada, yada, yada. How do we know when we're finished? Look at the exponent. If it is 2 or higher, you have to go through the list again and keep trying. If the exponent is down to 1, it can only have a greatest common factor or be a grouping problem, okay? Okay. That's fine. Okay. Halfway, party's almost over. What a bummer. Okay, so for A, I think we got -2. I think we got these results, -2 and -1. Okay. Let's see. For C, I feel like these are all good. E and F, these look good as well. Notice that they got the X is not equal to 2. Okay. All right, so we've explored, again, combining functions, basically doing arithmetic with multiple functions, adding functions, subtracting functions, multiplying functions, dividing functions. So then there was another concept called a composite function, right? So if f and g are 2 functions, the composition of f with the function g is written as f composed g. So this open circle, right? This is read f composed g. And it's defined by the equation f composed g of x is going to be f of g of x, right? So again, this open circle here, that's called composition of function. What it means is the second function inside the first function. Can anybody guess what's the common error that students tend to do here? Can anybody can you guess what's the common error that students tend to do here? Anybody know what that is? What do you think that is? No takers? So the common error here, sometimes students try to multiply. This is not multiplication, right? What this means is the second function inside the first function, right? So when we start working examples, like we're going to write f of x like normal, but we're going to replace each x with the second function, okay? And then when we go to find the domain of a composite function, there's a 3-step procedure that I recommend, that I tend to do. First, I find the domain of the inside function. Second, I find the domain of the simplified function. Then I take the third step is I take the intersection of those two results. And that's how I found the domain of a composite. That's been working for the longest. And that's essentially what this is talking about. Okay. So given this f and this g, we're asked to find each of the following. F of g of 1, okay? So again, what does this mean? This means f of, again, the second function inside the first, f of g of 1, okay? So what is g of 1? So that's just going to be a 1 plus 1, which is 2. I'll write it. Okay. Okay. So then what's f of 2? That's going to be 2 to the power of 3, which is 8. Okay. I'm going to shrink it down just a little bit because of that part that's protruding. That's good, just like that. Okay, so for B, we have g of f of 1. Again, this means the second function inside the first. So we're going to find f of 1 first. We get an answer, and then plug that answer into g. Okay. So g of f of 1. So this is going to be g of, what is f of 1? If we plug a 1 into f, we get 1. Because 1 cubed is 1. So then g of 1, that's going to be 1 plus 1, which is 2. Okay. Can I just duplicate that as well? Okay. That's fine. Okay. So then for part C, f of negative 1. Okay. So what's f of negative 1? Negative 1 to the power of 3 ultimately is going to be negative 1 times negative 1 times negative 1, which is ultimately just negative 1. And then it's a repeat, so the final result is just negative 1. I don't know why this is so exhausting. Ooh. I think it's just like being attentive. I am standing up because I don't know. Every time I sit down to do this, I get sleepy. So I made a little tower so I can stand up and talk about this like I'm in front of a podium or whatever. But man, this is exhausting. Like I'm sweating. I'm like, man, I might just be out of shape too. Anywho, these look good. 8, 2, and negative 1. I think I got some extra pages in here. So you see the 8 there, the 2, and the negative 1. Okay. So given this f and this g, find each of the composite functions. Okay, let's give it a go. So the first one, it just means f of g of x, right? So f of g of x. Second function inside the first function. Okay, so this is going to be f of, now g of x is x squared minus 3. So what we're going to do is rewrite f of x like normal, but replace each x with the green thing. Okay. So first we're going to write f by replacing each x with the blank parentheses. Okay. And then what color goes into the blank parentheses? The green thing. X squared minus 3. Okay. So then now we just do algebra. So we distribute our 2. We're going to get 2x squared. That's a minus 6 plus 1 is ultimately minus 5. Okay. Do a little divider. All right, so for B, again, second function inside the first function. So this means, and we can go equals because it's based on the above line. And let's just get rid of this. So we don't need this. This means g of f of x. Okay. So what is f of x in this case? 2x plus 1. So all we're doing is we're going to write g of x like normal, but we're going to replace each x in g with the burgundy thing. Okay. So we got our x squared minus 3, and we plug the burgundy thing into the blank parentheses, 2x plus 1. Okay. So then if we FOIL that guy, let me see, 4x squared plus 4x, it would be plus 1 minus 3 is ultimately what? Minus 2. Okay. All right. And then for C, f of x, again, second function inside the first function. So that means we're going to be finding f of 2x plus 1. Okay. So we got our 2x plus 1, and we replace each x with the burgundy thing, 2x plus 1. So we need to distribute. I get 4x plus 2 plus 1 is plus 3. Okay. Oh, okay. All right. Two x minus 5, 4, 4, 2, 4, 3. 2x minus 5, 4, 4, 2, 4, 3. Delete. Delete. 2x squared minus 5. 4x squared plus 4x minus 2, and 4x plus 3. All right. So given this f and this g, find f compose g in the domain, and then find g. Okay, I like this. I'm going to do my best to try to finish out this example. Do I have some space? Okay, I do have some space, so I can work that. Okay. Let me actually get a copy. How many pages did I give myself? 2. Okay. We're just going to use this as a reference. Cut, paste. Okay. All right. We'll work with this. And I'll divide up my page. Okay. So then for part A. So first, let's go ahead and find f compose g. So this means the second function inside the first function. This means f of g of x. Okay. What's our g of x? Is the reciprocal function 1 over x. Okay. So then what we're going to do is write f like normal, but replace each x with the green thing. Okay. So then that's going to give us this. We're going a little bit faster just in the interest of time. Okay. So this is the simplified. Now for the domain. So again, for the domain, there's a three-step procedure. First, we find that here. I'll write it here. So for the domain of composite function, first we find the domain of the inside function. Then we find the domain of the simplified function. And then last, we take their intersection. Okay. So then if we do the inside function first. So if we look at G, that's going to be the domain of G. We got the reciprocal function. It's a rational function. In general, the domain of a rational function is all reals except any x that makes the denominator 0. So the domain of G is going to be everything except 0, right? Because when x is 0, it puts a 0 in the denominator. So then next, let's find the domain of the simplified function. Okay. The simplified function is the answer that we have in the box on the left-hand side of the screen. The only restriction there, again, is that we can't divide by 0. So that domain, let me see, domain of the simplified function, in this case, is also going to be x not equal to 0. So then if we say everything except 0, intersection, everything except 0, so then we take the intersection. X not equal to 0, intersection x not equal to 0 is going to be equal to x not equal to 0. Okay, so a set intersection itself is going to be itself. And then we should write this in interval notation. So, like for instance, if we were to graph this guy, say this is 0, we're talking about all the numbers to the left is 0, all the numbers to the right is 0, and to capture that, we're going to use parentheses, okay? So then to translate this to interval notation, the far left is going to be negative infinity, the far up to 0, and then we want to go from 0 to infinity. Infinity always gets parentheses. Again, we get really close to 0, but we don't include it, so we're going to put a parentheses there, and we combine these with the union, okay? So let's duplicate. And I think that's all that we have time for today's style. You definitely want to use my recordings to go through the examples that we didn't get a chance to finish. We got about halfway through. We didn't work out B because we just ran short on time. Are there any questions? Let me go ahead and make a copy of this where you guys think if you have any questions or not. I'm going to make this available for you all. This one. Fall traditional notes.
Sorry, you're not sleeping though. You're talking about when I want to go to get you. Wait 1 second. You're 45 minutes late. Did you bring her to the store? No. What does she want?
All right, gentlemen. So let me see. Are there any burning questions before we go our separate ways? Going once, going twice. Let me check the chat real quick. You guys look good in the chat. Okay. So the only announcements, again, you can anticipate exam 2 to become available this Sunday morning at 11:11. You have full access for the first 7 days. Pat is due at the end of the 7th day. Past that, if you submit it, then there's either a 5% or a 10% late penalty, whatever it says, that's what it is. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend. And we'll meet back on Monday, same time, same place. For next week, so since next week is an exam week, more than likely what I'll do is on Monday, we'll do a review. And then on Wednesday, I'll probably just do some in-class office hours. I'll just check in, make sure you guys are okay, and then let you go on Wednesday. Okay? All right, guys. Take care. Have a great weekend. I'll see you next time. All right, gentlemen. So welcome. Oh, ho, ho, ho. Let me see. So hopefully everyone had a good, enjoyed your fall break. I want to sit down, but I'm nervous about sitting down because then I might fall asleep. So I'm standing. I got a little tower built. I'm using my iPad as a microphone, and it's this whole little get up. But hopefully everyone had a good fall break. To my surprise, on Monday morning, I was like, oh, I gotta get up. And then I log in at 9 o'clock. I was like, where is everybody? And then in an instant, I was like, oh, I bet you it's fall break. I checked the syllabus, and sure enough, it was fall break. So um so today we're going to be working on section 1.6, combining functions and composite functions. And I want to say that exam 2 becomes available this Sunday morning at 11 a.m. Um, you know, it's available for 7 days, and then after the seventh day, it'll be due. Any question submitted past the due date, there's either a 5% or a 10% late penalty. Whatever's there is what it is. Yeah. Okay. So let's just take some time to go through the content for today's lecture. Single page. Okay. And again, we're working on section 1.6, combining functions and composite functions, and a few objectives. One, define basic operations of functions. Two, form composite functions. Three, find the domain of a composite function. Four, decompose a function. And five, apply composition to practical problems. Okay. So sum, difference, product, and quotient of functions. Let f and g be two functions. The sum, f plus g, the difference, f minus g, the product, f times g, and the quotient, f divided by g, are functions whose domains consist of those values of x that are common to the domains of f and g, except for f divided by g, where all values of x that make the denominator 0 must be excluded. These functions are defined as follows. So the sum of two functions, f plus g of x, just means f of x plus g of x. The difference of two functions, f minus g of x, means f of x minus g of x. The product just means f of x times g of x. And the quotient is just f of x divided by g of x. Common error here. Common error. So oftentimes when students see this notation, they think, oh, I'm supposed to distribute an x. That's not what's going on here. We're not distributing an x. Okay. Again, this notation just means the function f plus the function g. This notation here just means the function f minus the function g. Again, I can't stress this enough. We are not distributing an x there. Okay, that's a common error that students like to do. And then when we divide two functions, when we say f divided by g, we have to remove any x that makes the denominator 0. Again, we can't divide by 0. Okay. So given this f and this g, we're asked to find the following. Okay. So let me start by getting a copy of this. I'm going to use this as a reference. Okay. And we'll do a little divider. We can get it working. Okay, that's fine. Okay. So for A, so we're asked to find f minus g, f minus g of 4. Okay, so what does this mean? This means f of 4 minus g of 4. Okay. So what is f? Okay. So then f is what? This x squared minus 6x plus 8. Yep. Oh, sorry. Back up. Getting a little ahead of myself. So let's evaluate f of 4, right? So there's going to be 4 squared minus 6 times 4 plus 8. Okay. And then minus g of 4. That's going to be 4 minus 2. Okay. Let me see. 16 minus 24 plus 8. Then minus 2. I think that this guy here goes to 0. So it looks like we finished with a negative 2. Okay. All right. Let's go ahead and do B. I think we can fit it here. So f divided by g of 3. So we're going to do f divided by g of 3. Again, what does this mean? This just means f of 3 divided by g of 3. Okay. So f of 3, we're going to replace each x with a 3. So it's going to be 3 squared minus 6 times 3 plus 8 divided by 3 minus 2. So that looks like it's going to be what? 9 minus 18 plus, that's not the color I chose. 9 minus 18 plus 8 divided by 1. Okay. That's a negative 10, so negative 1. Checking you guys. Okay, you guys look okay? We got some extra people in the house today? Let's see. Maybe not. I think it's just me and my 2 accounts. Okay. All right, so that was A and B. Let's look at C. So with C, we're asked to do f plus g of x. Okay. So there's going to be a f plus g of x. Again, this just means f of x plus g of x. Okay. No, I need it here. Okay. So our f of x, we got this x squared minus 6x plus 8. Again, plus in this case, g of x, which is x minus 2. Notice we don't need to distribute anything. We don't have any like multiplication over addition. We don't need to distribute any negatives. So we honestly could just lose the parentheses and combine like terms. That's going to be x squared minus 5x plus 6. Okay. Let's see, D. F minus g of x. So then f minus g of x. This just means f of x minus g of x. Okay. I'm just going to duplicate this and make the adjustment, duplicate. So instead of that being a plus, it should be a minus. Now in this case, we do need to distribute that negative. Okay. So if we distribute the negative and combine like terms, x squared minus 7x plus 10. Okay, I could put one more. Since we have two more, I'm going to use another page. Let me just copy this, copy, paste. Okay. Okay, so then for E, f times g of x, so then f times g of x. This just means f of x times g of x. Okay. Just going to duplicate again. Didn't go quite as easily as I thought it would. That's okay. I just have to cut it and paste. And again, this is multiplication. And I think we have to FOIL. Okay. So then if we FOIL, first times first, x squared minus, x cubed minus 2x squared minus 6x squared plus 12x plus 8x minus 16. We combine like terms, x cubed minus 8x squared plus 20x minus 16. Okay. And then for f divided by g of x, f divided by g of x. This just means f of x divided by g of x. Okay. I'm just going to duplicate and rearrange it to the proper form. Okay. So with a guy like this, right, we need to factor this guy. Anybody tell me, what does this factor into? Anybody? Can anybody factor this? Right. So, we want like an x and an x. Because the second sign is a plus, I know my two signs are the same. They're either both positive or both negative. Because the first sign is a negative, that tells me the larger number is negative. So if they're the same and the larger is negative, that means they're both negative. Okay. So it's going to be a negative and a negative. We're looking for two numbers that multiply to give us 8 in this case, and add to give us 6. I think it's 4 and 2. Okay. So then from there, you should see you get a cancellation. And we have to include the added stipulation because it's a rational function. Notice that when x is 2 in the original, we'll be dividing by 0. So we have to say that x cannot be equal to 2. If we were to look at this graph, it would basically be a diagonal line with a slope of 1, with a y-intercept of -4. And then when x is 2, there's going to be a hole or a gap in the graph. Okay. And so again, with this course, we expect you to have some level of familiarity. It's the best I can do. That's the best I've done with that word all day, but have some sense of familiarity with factoring, right? So this section does have a lab component associated with it. So hopefully, that's coming along okay for everyone. If anybody needs like additional, like a refresher review or practice on factoring, if we go into Blackboard and open up our main folder, the second link is going to say daily lecture notes box link. You open up that link, it's going to take you to an external app called Box. You can log in with your Morehouse credentials. And then, so the same way you access the notes, like folder number 4 is going to say handouts. Sorry. It's going to say handouts. In that handouts folder, there's going to be 2 documents. One of the documents is going to be a digital copy of an entire chapter devoted to factoring. It covers at least 90% of the factoring that we're going to experience in this course, right? And so it's a whole chapter. It goes through, again, like 90%, if not higher, of the different scenarios we'll come across, and it has practice. It's a copy. It's a digital copy of a chapter devoted to factoring. The second document is going to be a 1-page summary on how to approach a factoring problem. And so I decided to go ahead and include that in today's lecture. Delete, right? So this is a copy of the second document that you can find. And so again, whenever we have a factoring problem, this is a procedure or a set of questions we can ask ourselves, as we approach a factoring problem. First question is there a greatest common factor, right? Is there some factor that we can factor out of all the terms? If so, we factor it out. If not, then we ask ourselves, how many terms are we working with? Are we working with 2 terms, 3 terms, or 4 terms? If we have 2 terms, it might be one of these special cases where we have difference of squares, difference of cubes, or sum of cubes. Okay. And then, you might have to do a little bit of research to see how to work each of those special cases. But again, if we work in 2 terms, typically it'll be one of these 3 special cases. If we work in 3 terms or a trinomial, that's similar to the one I did on the previous slide. Whenever I'm working with trinomials, I pretty much do this method called the AC method of factoring, where I'm going to say my A times my C, I generated a number. Then I'm looking for 2 numbers that multiply to give me that number we found and add to give me B. And then from there, I kind of use this thing called the box method. You may have seen me do it once or twice, but that technique, I use that whenever I have a trinomial and I'm trying to factor it, I just use that one. They have several different suggestions here. Like you might have a perfect square trinomial, like the A plus B squared or A minus B squared. Or then you might have that where the leading coefficient is either a 1 or is not 1. But again, if you did the AC method like I described, or it's also called like the box method, it'll cover all those different scenarios in the trinomial. And then lastly, if you have 4 or more terms, you might try factor by grouping. So you might try factor by grouping. And then how do we know when we're finished? We look at the exponent. If the exponent is 2 or higher, then we have to go through the list again and keep trying. If the exponent is down to 1, it can only have a greatest common factor or be a grouping problem. Generally, that's correct, right? Because sometimes you get stuck at the squared, Yeah, essentially. Okay, that's fine. Okay. So I went on and included that. I think we got -2. There's a -1. I think we got these results as well. Okay. All right. So in the previous example, we explore what do we mean by combining functions. Basically, it's like arithmetic on functions. So given 2 functions, we explore how to add 2 functions, how to subtract 2 functions, multiply 2 functions, and divide 2 functions. So then there was an additional concept called composition of functions, right? Okay. So if f and g are 2 functions, the composition of function f with function g is written as this guy here. This is read f compose g. and is defined by the equation f composed g of x equals f of g of x. All right. So what this symbol means, it means the second function inside the first function. Okay. So again, composition. Can anybody describe to me what do you think is the common error that students make with this symbol? Like before, students tried, a common error was that students would distribute the x where that's not what you're supposed to do there. Can anybody guess what is the common error that students make when working with this symbol? If you really just look at that, and we didn't have this discussion about composition of functions, what do you think is a common error that students make here? Nobody? Any takers? Right. So a common error here is that students tend to treat this like multiplication, right? They'll try multiplying, and then that from that point on, it's a clusterfuck, right? So it just goes sideways from that point. This is not multiplication, right? What this symbol means, this open circle, what it means is the second function inside the first function. So when we start working examples, we're going to write the first function like normal, but we're going to replace each x with the second function, okay? And then for the domain of a composite function, there's a 3-step procedure that I recommend. First, we find the domain of the inside function. Then we find the domain of the simplified function. Then we take the intersection of those two results. And that's how we find the domain of a composite function. Okay. And that's essentially what this slide is talking about here. It's just showing how the domain of a composite correlates to the construction of it. Mainly, it's like how we describe that 3-step procedure. So given this f and this g, we're asked to find each of the following, okay? You have to give me, I'm a little bit like, so Wednesdays for me is like my Friday. So when I leave with you guys, my weekend officially starts. So then I just be like, I start swimming with like all the things I want to do. Like I want to go hiking, I want to go running, I want to meet up with this group, I want to catch this movie, like I want to take naps, I want to play the games, I want to clean. Like this is all this like this, I get excited. So anywho, and I'm watching the clock, and it just like I swear it just starts slowing. It goes slower and slower. I was like, come on! I mean, having like scrub moments. I was like, it's been 10 minutes for the past 30. That's what be going on my mind. It'd be so funny, and I just laugh and I just keep moving. Okay. Let's see. So we got this f and this g. Okay, and so the x is to find evaluate each of the following. So these are just evaluating composite functions. So let's take a look at it. So then for part A, f of this means f of, again, the second function inside the first function. So the second function is going to be g of 1. So we're going to find g of 1 by itself. We get an answer. We take that answer, plug it into the first function. Okay. I'm thinking I'm going to go here. So this means f of, let me see, g of 1, 1 plus 1 is 2. So then this really means f of 2. So if we plug 2 into f, we get 8. I'm just going to write 8. Like honestly, like when I leave you all, I got a lot of paperwork I need to do, but I'm going to do a couple of yards, like landscaping, just while I have energy as early as possible to maximize my daylight. Come back in. If hopefully I have the awareness to sit down and get caught up on some of my paperwork. Otherwise, if I shirk it off, it's just going to pile up, which is what I'm trying to avoid. So like responding to emails and stuff like that. Okay, so I feel good about A. Let's go ahead and work on B. G of f of 1. So again, the second function inside the first. So f of 1. Okay. So f of 1, if we plug a 1 in f, it looks like we get a 1. 1 cubed is 1. So then g of 1, that's going to be a 1, 1 plus 1. Duplicate. Duplicate. All right, let's go. And then C. Again, second function inside the first function. This means f of negative 1. Okay. So if we plug negative 1 into f, negative 1 times negative 1 times negative 1 is ultimately negative 1. And then we just evaluated f of negative 1, so this ends up being negative 1. That one was just a little bit redundant. Okay. So we got 8, 2, and negative 1. Like I need to update my attendance and everything. Okay, let's select 1, 2, 3, and I'd like to delete those. Okay, done. Okay, 8, 2, and negative 1. 8, 2, and negative 1. Okay. All right, given this f and this g, we're asked to find each composite function. Okay, let's just knock it out. So then for part A, f of g of x, what does this mean? This means f of g of x. Second function inside the first function. So what's the second function? X squared minus 3. Okay. So all we're going to do is write f of x like normal, but replace each x with the green thing. So I'm starting with my blank set of parentheses for each x, and then I plug the green thing into each blank parentheses. Okay, and then now we just use algebra to simplify. 2x squared minus 6 plus 1 is a minus 5. Okay. All right. Right here, okay. And then for B, we got g of f of x, g of f of x. This means f of x is what, 2x plus 1? Okay. And this weather is like, it's so trippy. Because I know there's a lot of people like, suffering, at least just in our neighbors to the north and to the south. North, they had the Hurricane Helene or something like that. And, they just got flooded. I don't know. I don't know if there's some, because I'm always, it just seems like our officials are just trying to wipe everybody out, poison us through the food, the air, the chemicals, chemtrails, the water. I don't know if there was cloud seeding at play, there was some evidence of that, but who can there's nobody, there's this shadow organization that, you can't track them down. You don't know who they are. They just have the power, and so, you got this town that has that was not prepared for flooding at all, and they just got decimated. And on top of that, supposedly some town, whatever town got flooded, is supposed to be in line to become one of those 15-minute cities. Same thing like with Hawaii. They agreed to become a 15-minute city, so they seem like it's a land grab where they potentially could have cloud seeded to cause it to rain just like in Dubai, and cause flooding. And then that way, if it's wiped out, they can just commandeer it. They can just take the land without, any pushback, and then they can just build it however they want to control. The minute you step out of line, then they can turn stuff off. And it's like, if you, hey, do what we tell you to do, or we're gonna turn your stuff off. And so that's why it's so important to be able to do for yourself. If you're dependent on these organizations, they're just trying to control you. It's much easier to fool somebody than it is to convince someone that they've been fooled. But then to the south, you got everybody that's like stuck on the highways. They're running out of gas, trying to escape the income. I think that's going on. Several other hurricanes incoming, and there's also evidence of possible cloud seeding and like record-breaking like surges and wind speeds and things of that nature. Apparently, like the highest the hurricanes can go up to was like a Category 5. But there was no limit on how high Category 5 could go. So now they're reconsidering, well, should we make higher categories? But I don't really think in this day and age that any of this stuff is natural. It doesn't really, And it could be. I mean, there are some other cycles at play, you know. But and then so like we have all this chaos, and I look outside right now, and it's like beautiful. You know, maybe it's the calm before the storm. Who knows? So that's another reason I'm a little bit antsy because I kind of want to be out in the weather, just soaking up whatever. I don't know if that's an artificial sun. That's another one you can look it up. The artificial suns that are being launched. Does it play? It's so much like weird stuff. Apparently, we have a second moon now, right? So then, if you know the moons affect the tide, and now we supposedly have a second one, so then that could be a culprit, right? I don't know if these satellites are artificial or not. You know, so it's just interesting things. I'm not saying it for any reason. I'm just saying it because it's interesting. You got to do your own research and decide for yourself on how you feel about this stuff. Um, yeah. So anyway, I am ready for my weekend, but yeah, let's keep going. We're almost done. Well, we're not almost done, but we got like about 20 minutes left in class, maybe more like 15 minutes, less than 15 minutes. Okay. So then g of 2x plus 1. So we're going to write g like normal, but we're going to replace each x with the burgundy thing. Okay. So then this is going to be x squared minus 3. And we're going to replace each x with this, 2x plus 1. So then we have to FOIL. That's going to become 4x squared plus 4x. 1 minus 3 is going to be a negative 2. Duplicate. So, you know, if you have like, you know, loved ones or family or friends affected by any of these, either trapped trying to escape Florida or caught in the floods in up north, you know, just sending love and light to everybody and hoping that everybody's safe and protected. You know. Anywho, okay, let's duplicate this. Okay, and then for C, so f of x. Let me change the stuff around. We don't need these guys, and we can rewrite. We can do like this, right? Because it's based on the above line. So f of x. What does this mean? This means the second function inside the first function. Okay. Let me check on you guys. Look okay. So then f of x is 2x plus 1. Okay. So then we're just going to write 2x plus 1. First, we replace each x with a blank parentheses. Then we plug the burgundy thing into the blank parenthesis. We have to distribute. That's going to be what? 4x. 2 plus 1 is a 3. 4x plus 3. And then, like, you know, this, I feel like life is too short to take things so serious, right? I still feel like do the best that you can. If you knew better, you could do better. You know, just do your best. But then once you've done your best, and nobody can tell you what your best is. People are always going to be extra critical. They're going to be like, no, you could have done better. But then you're like, well, this is my level of awareness. It sounds like a cop out, but that's one of those things that you kind of have to like kind of guard and protect because people are always going to be critical. It's easy to kind of like be critical of somebody, but then why don't you get out there and show them how to do it? For instance, and I'm just kind of filling the air really, just because it's an interesting story. At least I found it interesting. It might not be interesting, but it was interesting. But there was a story of like this artist, and he's like, you know, world renowned. I don't remember any names, but he made this work of art, and he put it in like public, like someplace like Times Square or someplace like that. And he left a note next to the art. He was like, if he left some supplies like markers or paint or whatever, and he left a note that said, you know, use these supplies to mark any errors that you find, like any errors, any mistakes that I made. So he left it overnight, and he came back the next day. His painting was like all marked up, and he took it hard. Because he takes his work serious. And so when he saw all these marks in his painting, he was really sad, and he like stopped painting for a while. And then his mom talked to him and was like, yo, this is how she said it to him. Yo, hey, yo, kid, you know, I was kidding. But she was like, look, if you want to stop painting, that's fine. But before you do that, let's just try one more time. She was like, do another painting, and leave it in public. But this time, instead of having them mark the mistakes, leave the supplies and say, if you see any errors, use these supplies to correct the mistakes. You see what I'm saying? It's easy to be critical, but who's actually going to take the time, to actually put these things in order? So he did that. He did that. He did what his mom suggested, did another work of art, put it in a public place, made that change to the note. And he came back the next day. It was nobody messed with it. I was like, and that was one of the stories I heard in one of those conspiracy TikToks. And I thought about it. I was like, damn, that makes a lot of sense. Like I've recently started, working out, and I was streaming with just like friends and family. And then sure enough, people were critical. They was like, you shouldn't do this or you shouldn't do that. And I'm thinking to myself, okay, you're being critical. Why don't you come here and show? I didn't say this to him. I just remembered this story. I was like, okay, you can find my mistakes, but why don't you come and show me how to do it the right way? I didn't say this to him. This is what went through my mind. So I say all that to say, do your best, forget the rest. I feel like again, life is too short to take it so serious. It is easy to be critical, but those critics, have them come and show you how to do it the right way. And 9 times out of 10, they ain't got the time or the patience or the energy or the focus. They don't have what it takes to do it. So, don't sweat the haters. Don't sweat the small stuff. Do your best, forget the rest. Don't stress and be blessed, right? Let's go. Okay. We closed it out and we brought it back. Okay. So let's go on. We still got a solid 10 minutes, give or take. But I just thought it was an interesting story and I just wanted to share it. Let me select. These are extra. We're going to get rid of these guys. Delete. Okay, that looks good. Done. 2x squared minus 5, 442, 43, 442, 43. Okay. All right. So given this F and G, okay. So I do want to try to get through this. For my earlier group, like my 9 o'clock didn't make it this far. My 2 o'clock, we got through part A, but we didn't get through part B. But this will give us an opportunity to showcase how to find the domain of a composite function. Remember earlier, we said to find the domain of a composite, there's a 3-step procedure. First, we find the domain of the inside function. Second, we find the domain of the simplified function. And then third, we take the intersection of those two results, right? So let's start by getting a copy of this, and we'll work on A. Maybe, depending on our time, we might get through B. So I'm just getting a copy right now. That's fine. Another quote, and I can't remember the verbatim, but I can remember the gist of it. It's a quote by Deepak Chopra that goes along the lines of again, when we have this urge to be critical of others, or when people are critical of ourselves, when we want to be critical of others, we got to remember that everybody, and even when we're critical of ourselves, I use this mostly on myself. We have to remember that everybody's doing the best that everybody's doing the best that they can from the level of awareness. Chances are, if we had the same experiences as them and thought the same way, we will behave in the same manner. So because everybody's doing the best that they can, give everybody grace, because chances are if we knew better, we would do better, right? So you can't just tell somebody the truth. You can tell them, but it won't register until they're ready to receive it, right? The truth cannot be told, it can only be realized. So a challenge that I've given myself, I used to kind of beat a dead horse, and then I realized this is a waste of time and energy. What I'll do now is okay, if it's something that I feel, because I'm a truth seeker, I'm always trying to get to the truth of things, and then just try to deal there. I'll say it once, whatever I think is the truth, and then I'll release it. I don't go back and forth. I don't try to push it on nobody. I feel like my job is at least to bring it to their attention, and then I have to turn it loose and give them time to realize it. there, again, the truth can't be told; it can only be realized. So you got to give people space and time to arrive to the same conclusion that you did, but you can't say it. Even with you all. Me saying this stuff is one thing, but it don't really sink in until you start, on your own, start asking questions and you start digging and you start researching yourself and you try this stuff yourself. Me saying it, that's one level. I'm really just trying to bring it to your attention. But it's up to you all to take your time, sit down and start asking questions. And then once you start asking the right questions, you'll get the right answers. Right? If you're not getting the right answers, 9 times out of 10, you're not asking the right questions. Right? So anywho. Okay. So let's see. So with this part A, let me start with my little divider. It won't let me go the other direction for whatever reason. It looks crooked, but whatever. As far as slanted or whatever. So for part A, so F composed G. So F composed G just means F of G of X. Okay. So this is going to be F of now G of X is the reciprocal function 1 over X. So then all we're going to do is write F like normal, but replace each X with the green thing. So then we're going to have 1 over X plus 1. Okay. So that's the simplified function. I consider this to be what's called the simplified function. Okay. So then it asks us to find the domain, right? So again, to find the domain of a composite, let's take some notes here. So to find the domain of a composite function, first we want to find the domain of the inside function. And then we want to find the domain of the simplified function. And then lastly, we want to take their intersection. Okay. So then the domain of F composed G. Okay. So 1, we want to find the domain of domain of the inside function. In this case, our inside function is G, so that's going to be the domain of G. Okay, domain. So G is a rational function. In general, the domain of a rational function is all reals except any x that makes the denominator 0. So the domain here is going to be basically everything except 0. So we're going to say x is not equal to 0. Okay. Then we need to find the domain of the simplified function. Okay. Domain of the simplified function, that's going to be the domain of this 1 over x plus 1. And the only restriction there, again, is we can't divide by 0. So it's going to be this. It just happened to be the same thing, x not equal to 0. And then lastly, we want to take the intersection. Okay. So this intersection itself is going to be itself. So a set intersection itself is itself. If we were looking at this in a graphical sense, say this was 0. If we want everything except 0, that means we're talking about all the numbers to the left, all the numbers to the right, and everything except 0. And so then from this graph, to write this in interval notation, the far left will be negative infinity up to 0, and then 0 to positive infinity. Infinity always gets a parentheses. Because we don't want to include 0, that gets a parentheses, and we combine these two sets with the union. Okay. Nope. Come on. No, that's not gonna work either. I'm just trying to. There we go. Okay, so we are out of time. Okay. Are there any burning questions before we go our separate ways? Are there any burning questions? While you think of questions, let me go ahead and make a copy of this available. Come on. Docs. Fall traditional is notes. Come on. Updated daily. Okay. So we'll drop it there. So when this little window closes out, you'll receive a copy of anything that you saw me writing. So now we didn't get through all. We got about a little past halfway as far as the lecture. So anything that we didn't do together, I do expect you to use my pre-recorded lectures. Uh, Also, keep in mind again, exam 2 becomes available the Sunday morning at 11 a.m. You have 7 days to work on it. It's due basically 7 days later. Past the due date, you can still submit it, but then there'll be either a 5% or a 10% late penalty on any question submitted past the due date. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. Next week, because this is an exam week, Monday we'll do a review session, and then Tuesday I'm just going to use as in-class office hours. So sorry, not Tuesday, but Wednesday I'll use as in-class office hours. So I probably won't keep you. Just check in, get your attendance credit, make sure you're okay, and then we'll resume our normal operation after that. All right. Have a great weekend, gentlemen. I'll see you next week, same time, same place for the next installment. Take care. Peace.